Ladies and gentlemen, now we move to the next session. We are honored to have Professor Eiji serving as our moderator for our session with the esteemed keynote speaker, Professor Eiji Nawata. I would like to provide a concise introduction to our moderator. Professor Eiji is a distinguished professor in the Faculty of Forestry and Environment at IPB University. Her research expertise encompasses forest ergonomics, occupational safety, and extreme heat exposures. So, Professor Effie, without any further ado, I now respectfully hand over to you as the moderator for this session.
Thank you. Thank you very much, Ms. Tia Amelia. And very good morning, Professor Ernan Rusjadi.
Morning.
Also, Professor Anuraga Jayanegara.
Morning, Prof.
And also all of the distinguished and esteemed audience that's joined with us today. I will be the moderator for these second sessions of for the second session, which is we already invite Professor Eiji Nawata from Kyoto University. Do we have Professor Eiji Nawata join with us right now?
Yes, already.
Okay, thank you. Thank you. Welcome to Indonesia to Bogor. But I know you are in Kyoto because we are doing...
Not in Kyoto, in Bangkok.
Oh, in Bangkok. Okay. Oh, okay, okay. Okay, Professor Eiji Nawata is the professor from Kyoto University, Japan, and he did a lot of research on agriculture sectors with expertise on the agricultural resources in the tropics, and then also evaluations of agricultural system, stress physiology of tropical crops, and crop evolutions of tropical crops. Today, we are going to enlightened by Professor Nawata with his presentations entitled Present World Crops Productions and its a Future Prospect. I think this is a very interesting topic. And then, without further delay, I extend warm invitations to Professor Eiji Nawata to commence his presentations.
Okay, thank you very much.
Anytime you're ready.
Yes. So may I share my slide?
Yes, sure.
I'm not sure. Is it okay?
Yeah, we can see it very clearly. Thank you.
Okay, so let me start. So at first, I'd like to show my gratitude to IPB old friends, especially Dr. Ernan, and to give me this opportunity. Yeah, you look very healthy and fine. So at first, I'd like to show my personal history first, but anyway, because of the time limitation, the Dr. Effie has already introduced me. But anyway, 4 years ago, I retired from the Graduate School of Agriculture, Kyoto University. And 1 year before the retirement, I made director of Kyoto University ASEAN Center, located at Bangkok. So after the retirement, I was generally staying in Bangkok. So today also I joined from Bangkok. This is today's contents. So no need to say anymore. We are under the climate changes. And now at Dubai, the 28th COP28 is being held for the discussion for how to counteract the global warming, because global, according to the IPCC, the global temperature is more than 1 degree higher than the average between 1850 to 1900. And this causes, as there is no need to mention, but the increases in the climatic extremes like the drought and the floods, and various adverse effects on activities, including agriculture, has been already appearing. A negative impact of global warming on agricultural production is listed shown here. Actually, in the tropics, the temperature is originally high, so small increase of temperature has a lot of small influences, but the big influence is the increase in the climatic instability. So rainfall is always not so stable, but instability is much more. And seasons, agricultural season may be more unstable. And incidences of natural disaster also increased. And increase in carbon dioxide emission. This may have some positive impacts I will explain later. But anyway, carbon dioxide emission causes more warming trend and reduction in productivity by increasing respiratory activities. If the threshold, the temperature exceeds the threshold, the productivity is reduced. And qualitative influences of warmer temperature weaken. So the flowering activity is flowering or tubulization, all some of the physiological event is heavily affected. But under such conditions, world food production of three major crops, three major cereals, rice, wheat, and maize, in 2021 is about 2.7 billion ton. 2.7 billion ton is a very huge amount, and it's rather difficult to imagine. But annual three major cereals consumption per capita is, this is the Japanese average, 200 kilogram per year. And if we apply this to the world food production, 1 ton of cereals can feed 5 people per year, and 2.5 billion ton of cereals can feed more than 12 billion people per year. Please, please memorize this figure. Our present population is a little bit less than 8 billion. So every year we have the surplus, which can feed 4 billion people. Of course, this assumption, this calculation is based on the assumption that all the produced cereals is used as a food and distributed fairly and equally. And this recent high and stable productivity could be realized by the development of agricultural technologies, and development of agricultural sciences contributed a lot, and I will explain later. And general political stability during these 3 decades also contributed to the stable production. So the data I've shown is based on the FAO stat. So agricultural statistical data provided by the FAO. I used it, but the last year's data has not yet provided by FAO. last year, the influence of what happened in Ukraine may have some influences, so I'm waiting for the data. But anyway, general political stability in the world may contribute it to the high and stable productivity at present. And I think some positive impacts of global warming may affect this stability. But anyway, I'll explain later. So I have already explained this figure. Now the production of every year can feed more than 10 billion people. And for these several years, the world major crop production is very stable, as you can see in this graph. Even though increased climatic events such as drought and food and large El Nino event has occurred 10 years ago, and the new El Nino started this year, and COVID-19. Under such condition, still the production is stable. And you can see that each crops increase. In comparison to 30 years ago, all three crops increase the production very much. And the red line shows the harvested area. So harvested area is also increased, but not much increased. So the increase of the production is caused by the improvement of the productivity of each crops. So maize and rice, both of them, the increase is very big. And this is the this is the production, and this is the yield. And so this kind of the improvement of productivity is induced by the development of agricultural scientists, high-yielding varieties development, or application method of fertilizers optimized, and the plant protection methodology has been developed, and irrigation and drainage system could be well established, and agricultural machineries are also developed very much, and cropping systems are generally optimized. And these new development technologies are distributed by the effort of agricultural extension workers. And I have already explained general political stability also contributed the stable high production in the world. And I have already explained positive impacts of global warming. Of course, there are lots of negative impacts of global warming on the productivity. We should recognize some positive impacts. Actually, the increase of carbon dioxide concentration usually give the positive impact on the plant production because the photosynthetic activity is increased. And this is usually considered. But other factors, expansion of cultivated area to higher latitude or higher altitude, and extension of cropping season by warming, and expansion of cultivation of highly productive tropical crops, most of them C4 plants, to higher latitude and altitude area. They are all positive impacts of global warming. So at present, it seems to me that positive impacts of global warming exceeds the negative impacts when we consider the production in the world.
はい。
And from now, I'd like to talk about the contribution of tropical area. Tropical area, the SEA means the Southeast Asia, Southeast Asian area, to the world crop production. In maize, actually maize is the tropical crop, tropically originated crops, but the actual production is mainly done in the temperate area. But now, the recent during the recent 3 decades, the production is much increased. And rice is also tropical crops, and originally the tropics show the contribution to the world production, but still the contribution is bigger. And this is the yield. So formally, the gap between the world and tropical average yield is big, but nowadays this gap is becoming smaller. Rice is also the same. And this is these tables shows the actual productions in maize and rice in Southeast Asian countries. Actually, Southeast Asian countries, the now ASEAN member states is 11 countries, but I selected big agricultural producers. That means in mainland Southeast Asia, I selected Myanmar, Thailand, Vietnam, and insular Southeast Asia, I selected Indonesia and the Philippines. And they show the big increase in maize production during these 3 decades. And rice is originally the production was big, so the increment is not so much in comparison to maize, but still the production is increased. And this is the improvement of yield. During these 3 decades, increase in the yield is very big, both in maize and rice. And this table shows the stability. In these 5 years, you can see CV is the coefficient of variance. If generally, if this figure is less than 5%, stability is very big. So actually, Indonesian maize production is exceptional, but this is not because the yearly fluctuation is very big, but because the straight linear increase. So this large value does not make problems. And rice, most of the country shows the stability less than 5%. The exception is Thailand, but Thailand rice production received a very big impact of the rice policy in that country. So under this situation, the stability of rice production is very big in every ASEAN member states, I think. And so this is the, oh, sorry. This is the rice, oh, sorry. Oh, this is the recent stability of the rice production in mainland Southeast Asia and insular Southeast Asia in comparison to the world. So everywhere, the stability is, if the statistical data is combined in its larger area, the stability is big. And yield is also the increment is very big, but in both mainland Southeast Asia and insular Southeast Asia. So anyway, the presence of the tropics and Southeast Asia is much larger during these 3 decades in the world crop production. So maize is increased in both production and yield, and this is caused by the development of new varieties and development of cultivate technologies. And the rice is a lot smaller increase in production yield in comparison to maize. And in some countries, rice policy is really affected. And these 30 years trend clearly shows the high potential of agricultural production in the tropics. High temperature, intense radiation induces a long agricultural season and high productivity. So maybe at this moment, the global warming influence is rather smaller, I think. This shows the recent development of maize and rice production in the tropics and Southeast Asia. So still we believe there are some room for the further development in the agricultural production in tropics and Southeast Asia. And then future prospect. I'm sorry to show the same slide very often. I have already told you that present production is very big and stable. So as I have already explained, present food production can feed more than 12 billion people. So no problem for food security for the future. I want to say yes, but no. There are many issues and problems in sustainable agriculture production in the future. First is the global warming. And I have this slide also show the second time there are many negative impacts of global warming. And as I have already told you, positive impact of global warming is now appearing and exceeds the negative impact. But soon the negative impacts may exceed. And the problem is when. And the population growth is not stopped yet. As you know well, now the world population is closing 8 billion, and some more increase is anticipated. And personally, this is the biggest problem. Energy consumption. The present agriculture is energy consumed models. I'm sorry, this data is rather old. This data is calculated by the Japanese investigation nearly 30 years ago. But 30 years ago, at that time, already the energy consumption for agriculture production is very large. This figure shows 1 unit energy. In order to produce 1 unit energy, how much energy is necessary? So 1 kilocalorie of rice production, nearly 0.9 kilocalorie of energy is necessary. And fruit and green meat, the vegetables, and fish and fish and the meat production, probably 3 to 4 times energy is necessary. So what kind of energy is necessary for the agriculture production? Chemical fertilizers production, pesticide, herbicide, these agricultural chemical production, we need energy. Agricultural machinery, we need energy. Post-harvest technology also needs energy. And new cultivar development or new technology development also needs large amount of energy and environmental control. In temperate area, this is also the big issue. So actually, energy saving technologies are the key issues for the future. So because of the time limitation, environmental degradation, and the balance between urban and rural area, I will skip the explanation. And so in order to solve these issues, what we can do? So this is my personal thinking that in order to solve the challenges for for future agriculture sciences, these are necessary. So at present, this trend is very big. From productivity stability. Formerly, we aims to increase the productivity, but at present, to maintain the productivity is more important. And technical adaptation to GW, means global warming. This is actually, at present, most of the agricultural scientists are accumulating the effort to this. And we can see many actual examples. And we need to establish new agricultural systems. So this, I show this slide for explaining the positive impact of global warming. Probably benefit by the carbon dioxide concentration increase is soon dismissed by the negative, exceeded by the negative impact. But expansion of cultivated area or extension of cropping season or expansion of the highly productive crops to higher latitude and altitude area could be the one of the how should I say, the positive mechanism to develop the agricultural systems. So we need to consider this kind of issues. And among them, cropping systems should be more elaborated. So optimization of another effort to optimize the cropping system should be considered. So adaptation to extended crop season or development of new cropping sites or adaptation of crop management to the new system or development of new cropping patterns or development of adaptive new genotypes. These are the very important since then. And other issues, food safety, actually, at present, a large surplus of food observed every year, but because of the food safety policy in each country, hindered the establishment of sound food system. Now food is one of the strategic commodity for each government. So at this moment, even though every year we produce the large surplus of the food, it cannot be distributed to the really troublesome people. And as I have already explained, energy-saving technologies are very important from now. We consumed a large amount of energy for the agricultural production. And also, molecular biology is utilized at present, and microbiology is also, microorganisms potential is very big and not free developed. So the efforts to use these 2M technology is very important. And nowadays, the farmers' ages is getting older and older. So I think Indonesia is the same. So smart agriculture technology and rural development should be the major concern for us. So that's all for my talk. Thank you very much for listening.
Thank you, Professor Nawata. That was a very enlightened presentation, yeah, because it was quite or very different a perspective that you said. It's that totally on contrary to our assumption at first that climate change effect will definitely decline the crop production, but you mentioned the data that's up to now from 1989 there was increasing productions in the crops and maize. So it was new information for me actually, and also I think all of this audience here. So and but also you mentioned another words about when this tendency has the potential to be going in the contrary way. I mean, because we know that climate change effects is give a very, how to say it, actually it gives a severe effects. For example, when we talk about smart agriculture, now we found that the productions of these farmers who working abroad is going decreasing more and more because they and we conclude that this the rising temperature is one factor that responsible for this lower work ability of this farmer. So is there any audience who want to ask, or for example, want to share your queries or thoughts? You can type your name and institutions in the chat box, and I will read your questions for you. And then while we are waiting for the audience to questions, I have one questions for you here. What is your opinions regarding to this to your previous presentation in which you mentioned that South Asian country have because most of us in the tropical regions, we will have I don't know, I can't say that's a bright future, but at least it's a positive or beneficial geographical I mean locations while we facing the climate change issue in the term of food security. So what is your opinion on this?
Actually, temperature and the water point of view, the tropical area, especially Southeast Asian area, is advantageous. But another issue, the soil property.
Yeah.
Actually, most of your country soils are not very good, except for some volcanic affected areas.
Yeah.
So I'm not sure whether there is a room for the development, for example, paddy fields, further development of the paddy fields or not. Some area is not suitable for the paddy paddy production, and some area is very suitable, but the over exploitation always causes some problems. But still, I think there is some possibility or room for the further production increase in the production of rice and maize. And maize is apparently the production of your the Indonesian production of maize is increasing, and
Oh, yes, thank you. I just thought about this idea. I don't know whether this is crazy or something, or possible or impossible according to your expertise, but I think that we have a lot abundance of sunlight. We have the sunlight a whole year through, and then what if we, for example, directing the smart agriculture into what we call as hydroponic paddy fields?
Mm. Hydroponics is able to apply the vegetables or high-valued crops, but
Not paddy?
not paddy. It's rather difficult
Okay.
because it is also the energy-consuming agriculture.
Okay.
Mm.
Okay, and this is the last questions. I think we still have 1 or 2 minutes. From Mr. Nur Rahman, he asked you about how is Japan itself dealing with the global warming and what strategies are being implemented so far.
Actually, just like your country, in Japan, we have the prefecture level agricultural research stations, and also National Agriculture Station have their branch in each region. And the researchers there actually started their effort to adapt their varieties or their cultivation technologies to the new environment. So it's rather difficult to show the actual example here, but some northern prefectures already started to make the trial for the more warm area adapted genotypes there. So, and I heard some prefectures or some area already adopted new varieties. And they are also checking the, how should I say, the new agricultural seasons. Formerly northern area, the agricultural season is very short, but now the agricultural season may start earlier. So new varieties or new technologies adapted to this kind of change is quickly being developed.
Okay. Okay, thank you very much, Professor Eiji Nawata. I think we still have a couple of questions actually, but unfortunately, we're already limited by time because after this, we're going to have parallel session soon. So I'd like to say special thanks to Professor Nawata for your valuable insights and open a door with 確信していました。どうもありがとうございました。
どういたしまして。Thank you very much.
Thank you
Thank you
very
very
much.
much,
Terima
Professor
kasih.
Nawata.
Thank you very much.
Devi.
And then, as your moderator, I also would like to send my gratitude and thanks to all of the audience. And I now hand back the control to the master of ceremony. Thank you. Thank you.
Okay, thank you very much, Professor Eiji and Professor Effie, for an exceptionally insightful and fruitful session. It is indeed an honor to us to have you as our esteemed keynote speaker and moderator for today's conference. So, the conclusion of the presentation by the second keynote speaker signifies that the conclusion of the plenary session. So, subsequently, we will transition into the parallel session, and all the presenters and the attendees are encouraged to transition to the Zoom rooms according to the presentation schedule. The committee has previously communicated the links for each subtheme via email and also provided them in the chat box. In my capacity as the Master of Ceremonies, I extend my gratitude and take this moment to bid you farewell. Thank you very much. Billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.